Hi, my name's Dan Espenson. I'm co-inventor at Quantum Properties along with Steve Alejandro, and we have invented a portfolio of patents. Combined, we have over 50 years of IT experience. Steve Alejandro is a world expert on AI, physics, and also mathematics. My background is in computer science and computing methods. Part of my background is something called NIDS, which is Network Intrusion Detection Systems. I was the inventor of that in the early 90s. That has to do with cybersecurity, and this is now my second series of patents, along with Steve Alejandro, having to do with cryptography and computer security. So we're coming at encryption in a very different way than most people. But together we have developed a mathematically proven, unbreakable cryptographic method. So there's something that NIST is concerned about, having to do with the quantum apocalypse, where all cryptography is going to be broken, but it turns out it's going to be all except ours, because we have a mathematical proof. For the past 50 years, data has been secured using what are called public keys. The way that public keys work is by creating a puzzle, which is easy to create but very, very difficult to solve. An example of such a cryptographic puzzle is if you take two prime numbers that are very large and you multiply them together, which can be done very, very quickly, you end up with this huge number. That's a fast process, so it's easy to create this puzzle. If you now take the product of the two prime numbers and you try to factor them back into those two prime numbers, that is a very, very difficult problem to solve. And that is how public key encryption has been working for over 50 years and has been very secure. However, with the advent of quantum computers and very, very smart artificial intelligence, AI, all of that difficulty is going to go away. And in theory, these kinds of puzzles will be very solvable very, very easily instead of making them very, very difficult. The problem is the government NIST organization has declared a quantum apocalypse. Puzzles, which have been securing us for all these 50 plus years, that used to be very difficult to solve, are going to be very, very easy to solve at some point. As soon as quantum computers are able to live up with their full capability, or artificial intelligence is able to live up to its full potential, these puzzles, which we are currently using to secure our data, aren't going to secure it anymore. And this again is called the quantum apocalypse. Quantum Properties patents have to do with developing a cryptographic method called OTP. And this OTP method has been around for a long time, but has been totally impractical. What's cool about OTP is that if implemented correctly, which is what we've done, it is invulnerable to both artificial intelligence and to quantum computers, no matter how powerful they get. How can we know that for certain? Because there's a mathematical proof that shows that that's the case. And the mathematical proof can't be defied. Doesn't matter how smart AIs get or how fast quantum computers get. Our method does not use puzzles. It uses something called OTP, and it will be unbreakable. And we have a series of patents which have been granted. We have one called NewTek, which has to do with securing data at rest, such as on storage media. We have one called SecNet. This has also been granted. And this patent has to do with secured data over networks. And then we have one called TringTech. And TringTech has to do with data in motion, in particular point to point. So we have data at rest, data through networks, and point to point. We have two additional patents, one on custodial keys, which has to do with who holds these long keys, and encoded keys has to do with the backing up of the keys themselves. Because if you lose, of course, your keys and the encrypted data is unbreakable, you will lose all of your data. So the keys have to be stored in a safe way. We have three major areas of encryption. One is for transportation and long-term storage of physical media, because once you have stored quantum properties encrypted data, it can never be decrypted by the wrong people, and that's no matter what breakthroughs happen in cryptography. Again, there's a mathematical proof that shows this. We also have a patented method for securely transmitting data across computer networks in a way so even if someone's listening to the entire transmission and then they have quantum computers or some other brute force method to look at that data, they still can't break the encryption. And thirdly, we have TringTech, which is point-to-point wireless communication, including key fobs to cars and private communication between two parties. Again, all of this totally unbreakable no matter what. Today we'll be showing a demonstration of our TringTech unbreakable encryption. And this is a prototype unit that we have. And let's take a look at it here. This is what the prototype looks like. There's what we call a Tring disk on top. And then there's a raw data area where you put in unencrypted data. And then out pops your encrypted data. The method used for this is something called OTP. It's been around since the late 1800s, except back then they couldn't encrypt binary data, of course. And it was proven unbreakable no matter what method you use by the US Army in 1949. But again, rarely used because in order for it to work, you have to have truly random bits. You have to have ones and zeros being generated in a truly random fashion. The methods for doing that were way too slow until just about 4 years ago. And now they're plenty fast. The generation of random bits can be as fast as 200 trillion bits per second. TringTech is a patented methodology. It uses truly random number generated key bits to secure your data. When secured by TringTech, encrypted data is mathematically proven invulnerable to all cryptographic attack methods, including brute force and quantum assaults. The inventors are myself, Dan Espenson, and Steve Alejandro. And we'll be encrypting some stuff here with our prototype, and then we'll be decrypting it. So we'll start with encrypting, and we're going to choose a file to encrypt. We're going to do this QR code file here. It's a nice one to encrypt. And let's start our encryption. The encryption will produce a .tcrypt file. So we have qp_qrcode.png. We're going to end up with qp_qrcode.png.tcrypt. So let's start our encryption process. And it says it has completed the process. And it used the Tring disk. And this is the Tring disk ID. Every Tring disk is also unique, besides the bits on it being unique. Let's look at here's the encrypted data. qp_qrcode.png tcrypt. Let's take a look at this with a binary editor. This is a nice binary editor that we use. And we can see that the data has what's called a header, which is up here, which is human readable. It has where our Tring random bits are, where we're starting with them, and then it has the ID of the Tring disk that we're using, and then it has all the random bits. And you can see these are all, well, these are all random bits anyhow. Now, let's decrypt this. Decrypt, choose a file. Okay, the chosen file is going to be this .tcrypt file, just like before. Start decryption. This is going to reapply random bits to all the bits that you saw in this tcrypt file, and that will then decrypt it. So let's start the decryption process. And it completed the decryption, and here's the result, is the QR code, just like we started with. So that's the entire process. What's really super cool about the Tring technology, again, is it cannot be defeated by any kind of brute force or quantum computers that are, millions of times or billions of times faster than current technology. Cannot be defeated by any of those things. It is 100% guaranteed, mathematically unbreakable. And this is what we've developed. The Tring technology can also be used to send email messages across the internet in a 100% guaranteed, unbreakable way, so that no one but the receiver can ever look at that message. And let's give it a shot here. There we go. We'll click on message. Message from, be me, email to, and this is where you put in the email address, which we're going to blur out here. And let's put in our message. Hello, Fred. Let's meet tomorrow night at 8 p.m. in the parking lot at a bank. Okay, here's our secret message. Let's send it. Okay, so TringTech is encrypting it, and now it's sending it. And the way it sends it is it takes the message text and it encrypts it into a file, and then it sends the email to the recipient. As an attachment is that file, which is encrypted. And then the receiver has to take that file and then send it to the decrypting part of TringTech. So let's take a look at that now. So we've received our TringTech message. Let's take a look at it. Hello, attaches a TringTech encrypted file. You'll need your matching Tring disk to decrypt it, and you will. If someone does not have the matching Tring disk, they 100% guaranteed cannot decrypt this. It is impossible, and mathematically proven impossible. Now we're going to take that file, we're going to put it into what's called the work folder. We're going to save it there. TringTech's going to notice it, and here we go. Message from Daniel Espenson. Hello, Fred. Let's meet tomorrow night, 8 p.m. in the parking lot at the bank. And there we go. 100% decrypted, working just perfectly. If you go to quantumproperties.ttinet.com, which is up here, quantumproperties.ttinet.com, you can read all about it. You can also look at all our patents. We currently have 3 patents that are granted here, and we have 2 pending patents. And the patents cover the transportation and storage of data that needs to be encrypted, forever, unbreakable. And then it has to do the transmission of that data through a secured network. That's granted. And granted, of course, is our TringTech technology, which we've just shown you. And the TringTech technology is for point-to-point transmission. Now this can include, for instance, you have a remote location somewhere and you want to put in a VPN, or virtual private network, and you can make it so that all of the data that goes between that remote location and wherever the VPN terminates is encrypted in a way, again, that can not be decrypted by anything. Doesn't matter what it is. Nothing can break it.